Very welcome, everyone, our new and old friends of ISS, Intelligent Institute of System Science. Great to meet you here. So thanks for your sessions here for these joining these from human intelligence to machine intelligence. Great. My name is Sam. My Chinese name is Zhan. Great. What is intelligence? For many of you, you may have different ideas of what intelligence is, what is human intelligence, right? There's so many definitions, but let's look at one of the definition of intelligence. Intelligence is a measurement. It measures a human's or a AI's ability to achieve goals in a wide range of environments. So this is a definition from Lex and Hutter in 2007. I tend to agree with that. So any examples? What about achieving goals in school environment? Any goals in the working environment and any goals in your home environment? Let's look at it. To achieve a goal in school environment. So we start to know how to pass the exam. But what's more, from this intelligent information retrieval system, which is a search engine, it not only gives you what you want, but also they try to guess your intention. Pass the exam through a very hard study is good, but how to pass the exam without studying? If you can even pass the exam without studying, is there some reflection of the intelligence? Yeah. So the search engine here have walked one extra mile to try to extrapolate what you really want to search for. Right? What about work environment? Right, you can seem to ask any questions and you can get an answer or a solution from a intelligent system like a search engine. Now search engine is getting more and more intelligent. So you will notice in the frame here, you also see people also ask, what does that mean? If you search for these, you are also likely to search for that. So this is actually a modern recommendation system behind the scene, right? What about achieving goals in the home environment? This is one of my favorite. How to make your spouse happy without spending too much money, right? Okay, for me, I'm a hopefully intelligent lifelong learning. And I hope all of you here are also a lifelong learners. Yeah. So my name is Zhan. I lecture the Master of Technology in programs in the area of data science, machine intelligence, soft computing, artificial intelligence. So I'm involved in a few programs in ISS, Master of Technology in Intelligence System, which is the AI degree. Master of Technology in Enterprise Business Analytics, which aims to grow data scientists and managers to practice enterprise business analytics. Also, we have a lot of other programs, professional conversion programs, and graduate certificate. So this is my family. My wife, she is a PhD in chemistry, and my 4-year-old son, at that time now is turning 5. So when I'm not lecturing here, I'm doing babysitting most of the time. So yesterday I went swimming with my son, Didi. Soon you will see the Didi very soon in the future slide. Okay, for human ability, human cognitive abilities, human intelligence, there's many capability of us. For example, abstract thought, motivations, modal control, so we can move our arms and to adjust my glasses. Right? So sensor processing, our visions, our language, our learning ability. So among all so many abilities, these are the 3 most important capabilities that we have. Long-term memory, learning, and reasoning. So these are the 3 most important capabilities we have as a human. So first, let's look at a human memory. Human memory is used to store data, store our abstract knowledge, store our sensory information, experience. including these ISS Learning Festival sessions as well. So memory enables us to remember, enable us to collect past experience, enable for the machines to collect past data in order to support the learning, Okay, based on modern medical imaging technology, we have mapped our brain to a few areas. We have notified that we have sensory memory sections, which stores short-term memory. Also, we have another short-term memory and also long-term memory. So there's different areas mapped in our mind that actually stores short-term memory and a long-term experience. So you can imagine those sensory information getting through our eyes, our nose, our ears, we hear, and our tongues, we taste, right? So those sensory informations are being temporarily stored in an area called sensory storage in our mind. Then the short-term memory is like a computer RAM. It needs power. If you power off it, then it tends to forget. Only those information that is useful and we as a human would like to retain it for a longer term, then they will be stored into the long-term memory. Okay, so we have a staggered area in our mind that stores information for different time durations. One side information for you. In order for a thing to be remembered in your memory in the long term for 5 to 20 years. Say, for example, some of our new friends of ISS, this may be the first time that you are seeing Sam. So you try to remember Sam's outfits and what Sam looks like, right? So how many times do you need to see Sam in order for you to remember Sam in the long run? So next time when you visit ISS, you can reckon, oh, this is Sam. This is Sam. So based on the modern memory scientific memory theory, you need to see Sam's image 7 times over the time span of 2 weeks. So from now on, this is the first time that you're seeing Sam. In the next 2 weeks, you need to repeatedly see Sam's image 7 times. Then it's very likely you will remember Sam's looking in the next 5 to 20 years. Okay, so this is a memory. So memory enables us to store data, store the past experience. So now we're moving to the learning. Learning is another very important aspect of human capability. So learning is a procedure. It takes in the input and generate the output. So what the output is being generated? The output is that generate a new knowledge. Generate a new knowledge, okay? And those are the information and data to memorize and reuse in the future. So I give you an example before we move on to the different type of learning. So in the past 5 years, I have been looking at Singapore's weather. I found that if in the morning it is very cloudy, it's quite likely going to rain in the afternoon, based on my 5 years data record in the past 5 years. And I also noticed for most of the days when it is not cloudy in the morning, then afternoon there was no rain. So I recorded all these weather data in my mind, in the memory section. So I stored it. So after I stored it, I start to analyze it. I want to figure out the pattern. Is there any rules or knowledge that I can extract in order for me to forecast the future weather? So I conducted them intangible learning procedure in my mind. I carry out that. So after scanning through the past 5 years weather outlook data that I captured in my mind, I generate new knowledge in the form of 2 simple rules. One is when it is cloudy, then it's going to rain. When it is not cloudy, then it is not going to rain. So the learning procedure has helped me to generate 2 abstract knowledge which can be useful in the future for me to predict. That will be in the reasoning part. So we are looking at the learning. So the key thing is you take in the raw weather outlook data in the past 5 years, went through this magical learning procedure, then it generates an abstract knowledge. In this example, I'm using a rule form. Okay, so that's a knowledge. So the key thing, learning. So let's look at some of common forms of learning in human. The first one is called habituation. You see the first picture on the left, there's a few birds there. Then with the introduction of the scarecrow, what happened? The birds fly away, right? But with a prolonged exposure to the scarecrow, the bird come back. So the bird learned there's no threat, no genuine threat of this scarecrow after a prolonged exposure. Okay, so this is a type of very common learning that is quite frequently being ignored by our human beings, but we are actually always using it, called habituation. So habituation is the learn to ignore, okay? Learn to ignore. So when we're mapping to the machine learning is a simulation of what a human really learns. So in machine learning, it is mapped into a group of unsupervised learning method or anomaly detection algorithms. Okay, think of in the banking sectors, when we are swiping our credit card in the POS machine at the merchant, so there are tens of thousands of legitimate transactions going through these payment channels, but there's occasionally some fraudulent transactions, right? So when we are building a modern fraud detection system in the bank, anomaly detection algorithm came into the play. So millions of thousands of legitimate transactions would provide to the learning algorithm. Then the learning algorithm will start to generalize and figure out what are the common patterns of a legitimate transaction. Say, for example, where the IP come from, what is the transaction amount, what is history of this account. Okay, then so the anomaly detection system learn to ignore those legitimate transactions. But whenever a fraudulent transaction come into the system, go through the system, then they find something is not right? Some weird situation, weird features, which seems to deviate from the mainstream. So that is a time, an alarm or an alert will be generated. So behind the scene in machine learning, anomaly detection is actually built on top of this habituation, which is our human learning. So the second common form of learning in human is called classical conditioning, or it's called reflex conditioning. Okay, you see there are 4 pictures from the left. When the dog sees the food, salivas are being generated, salivas. When the dog hears the ring bell, no saliva. But now, when we're doing the conditioning, we present the food together with the bell ring. Then the dog starts to generate saliva. So we repeat this again for a prolonged period. After that, then we ring the bell, the dog starts to generate saliva. So this is association between a stimuli, or called association between the events. Okay, association analysis in the machine learning is built on top of this classical conditioning. So the third one is called operant conditioning. This is the third common form of learning of a human being. You see in the left side there is a mouse. We call it a subject, or you can also call it agent. In artificial intelligence, we can also call it an agent. So this subject is put into a cage where the floor is electrified. So there's 2 important buttons there, green button and the red button. So initially the mouse has no idea what is the usefulness of these 2 buttons. So what the mouse tends to do, based on our common sense, the mouse will start to explore this environment, right? Randomly, somehow randomly explore the environment. So occasionally when the mouse touches the green button, there is food being dispensed in the dispenser. And sometimes when the mouse accidentally presses the red button, there is electricity shock. So after many time and many iterations for the mouse to explore randomly in this environment, we start to notice the mouse will always try to avoid pressing the red button. But at the same time, the mouse will try to spam this green button again and again for more food. Right? So this is a called operant conditioning. This is in machine learning is related to reinforcement learning or semi-supervised learning. So this is learned by reward or punishment. So the subject or the agent learns to perform a series of purposeful actions, which is guided by the reward and the punishment. The green button is a reward, the red button is the punishment. So the mouse learn to ignore those punishment and continue to ask for more reward by pressing the green button. So this is also what we do. So recently it's quite famous, AlphaGo from Google DeepMind, who has developed a piece of program called AlphaGo, making use of reinforcement learning. And that AlphaGo piece of software has won the Go champion, So behind the scene, it is actually reinforcement learning. So let's look at the next one. Next one is, again, now you see my son. So my son is an agent. My son utilized the operant condition or reinforcement learning to solve his problem. So my son Didi is a reinforcement learning agent here, and the agent name is called Didi. This environment that my Didi is exploring is the NUS campus near ISS. So my son has a goal. My son wants to move the scooters from the right side of the campus to the left side of the road. But it was blocked by this metal chain, as you can see, right? So let's see how my son solved this problem by performing reinforcement learning. Let's watch this video. So let's note here, my son tries to use force. But he failed to do that. So it's obviously that my son has no knowledge, no prior knowledge of how to solve this problem. So naturally he tries to ask help from me, but I'm a very cruel and AI dad, so I didn't help him. Let's see how he solved this problem. So he's moving here, near, lift the metal chain, he crossed it. He feels a little bit surprised, right? Did you notice? He moved back, look back, and he feels pretty surprised that the scooter has moved to the left side and he can continue his journey. So after he solved his problem, the goal has been met. After meeting the goal, what happened? My son got a reward. What is that reward? His happiness. He can continue with his journey. So this is a reward. So this series of action leading to the goal of solving this scooter problem is now being remembered and recorded in my son's memory. Okay, so assuming I'll ask my son to continue to do this again, my son will soon to find out, oh, that is one series of actions that can be performed. So now think of this. Can you build an AI model, intelligent AI model to predict some anomalies like these? What are the key indicators and features? So just now we have looked at this, my son solving the problem using reinforcement learning. Next is last one, observational learning. You see from the image, right? There's the observational learning capability are even demonstrated in some of the animals. Learn to drink the bottled water just by imitation. So in AI, it is called imitation learning, and it's largely unsupervised learning. So we need to learn by observing those role models. How my boss becomes so successful. I want to learn by my boss, but my boss is so busy that he has no time to share with me his secret of being so successful. So I need to constantly observe my boss and those role models without explicitly being told or guided or supervised on how to being successful. Okay, so this is observational learning. And you know, in nowadays, there's called robotic process automation or cognitive robotic process automation. So behind the scene, when a user is doing something, let's say creating a dashboard, creating a Excel chart, then there's a robot behind the scene, keep monitoring and record what the user was doing using his laptop. So next time, when the user wants to recreate a chart, then they just activate, hey, say, robot, please do this for me. So the cognitive RPA behind the scene will try to figure out what the user wants without being explicitly taught. Okay, so this is observational learning. So again, all these four common forms of learning, the outcome is the knowledge. Okay, this is a knowledge which can be reused to solve new problem in a similar context or a different scenario. Okay. So now we're moving to the reasoning part. Reasoning concerns about using the knowledge, applying the learned knowledge to solve problem in a new scenario. So again, using my previous example of weather forecasting, so I have recorded the past 5 years data. Sam has conducted this learning procedure. So the knowledge I obtained after conducting the learning procedure is the two rules. When it's cloudy, it's going to rain. When it's not cloudy, it is not going to rain. This is knowledge. So now with this knowledge, I can use it for what? I can use it to predict weather for tomorrow, the weather for the day after tomorrow, right? I can constantly reuse the knowledge that I learned. So today is still morning, right? So in order to predict the afternoon's weather, what I do need to do, I just go out, look at the skies. Is it cloudy or not cloudy? I found it's not cloudy, so I will predict it's not going to rain in the afternoon, right? So reasoning concerns about using the knowledge. The knowledge can be in different forms. Come to our course, then we will elaborate a lot of knowledge in different form. It's not just in rule form. So there's a few common forms of reasoning as well. Deductive reasoning, also formal logic, starting from Aristotle's time, 2,000–3,000 years ago. So I've been using deductive reasoning. Second is inductive reasoning. Inductive reasoning is indeed statistical learning or statistical recognition. Inductive reasoning is learning. So learning is inductive reasoning. To a broader context, reasoning involves the entire learning. This is one of the definitions, but in the context of for this talk, we'll try to separate them. Learning is learning, reasoning is reasoning. Okay. So analogical reasoning is similarity-based reasoning. We also have abductive reasoning, which is from hypothesis, from the evidence to prove the hypothesis, which is probabilistic thinking. So largely, you can see there's some overlap between learning and reasoning, although theoretically speaking, the entire portion of the learning belongs to the reasoning, but we try to split them. When we're splitting, we will say that inductive reasoning is very similar to classical conditioning, which is a form of supervised learning. Okay. So this is one of my favorite quiz. So on this image, you see there are 4 aliens and 4 non-aliens. So there is a question for you to choose which one is not alien from A to E. Okay, so this is a quite typical reasoning and learning activity involving our human cognitive capabilities. Generally, we'll go through 4 steps. One, first, we observe. We recognize the patterns and generate the features, those relevant information. For example, for the alien, we start to decompose this image. It seems there's 2 eyes. Some aliens is in gray color, some in white, or non-alien seems in gray color. There's a few legs of it. There may be some triangle, is it the nose of it? So this is actually, we try to observe, right? Then after that, we learn and recognize to form theories, candidate theory. So I guess an alien must have 1 nose or no more than 1 nose. So this is kind of a hypothesis, hypothetical theories that we produce. Right, next, that's a learning. Learning is to learn the knowledge. So hypothesis is a kind of knowledge. So next, we are moving to the reasoning part. We want to evaluate those hypotheses by putting in this ABCD into it. See whether this hypothesis or the knowledge can help us to classify the candidate answers, those choices A to E, whether they are alien or not alien. Our judgment is, the good theory is, it can single out only 1 alien and classify the rest of the 4 into non-alien. So that will be a good candidate theory, right? So we are using our learned theory, hypothetical theory during our reasoning session. Then after that, we have find a hypothetical theory. In the end, it is for problem solving. We need to make a choice. We need to select one of the alien from A to E. So we need to act. So that's a decision that is observable. Okay, after taking the act, we also need to bear the consequences, and also we observe the environment. So the teachers will tell us, okay, you made a good choice, or you make a correct choice, or you make a wrong choice, right? Okay, so we also use some in the real world where things are pretty fuzzy. So we see that there's Nicolas Cage on the right side, on the left side, and his hair was long at that time, so we grouped them into long hair group. So when he was in the movie with the short hair, we move it to short hair group. Then what about this person? Whether this person should belong to long hair group or short hair group. These are some of the things that as a human, we solve it quite naturally by ourselves. But how can we enable a machine to make a decision which group should they solve? So if you are interested, move on to our ISS course. Okay, there's many major sub-areas in artificial intelligence, including artificial neural network, which is a replication of what our biological neurons are working. So on this slide, you see there's 2 2 neurons here. This is 1 neuron, this is another neuron. So they are linked with a synapses. So each of the nodes are now mapped to each of the orange circle here, which is artificial neuron. So this is a field which is getting very, very popular. Deep learning is also deep artificial neural network. Other subfield like evolution computing. Evolution computing, we create a subject or agent. In the real world, there will be a small animal. They through the evolution and become more and more and fitter into the environment. So the fitter it is, the higher the survival rate, the more reproduction of that particular agent or animal, then it's more successful for that species. So there's a bunch of algorithm behind evolution computing. Next one is computer vision, driverless cars, autonomous vehicles. So they require all those visions. So identify all the objects from this image or from this video stream, figure out, then put into a sensor fusions, then conduct the reasoning. Should I apply the brake now or should I continue to drive? So last, you also see the robotics. Earlier, Mr. Nicholas has shared with many things about robotics. So this is a robotic dog here. And actually, we already see this system in Singapore. So this system is deployed in one of the parks in Singapore to enforce the social distancing. So the dog will walk with a camera there. When they notice there's two persons are too close with each other, identify two persons and their distance in the center is lesser than 1.5 meter, we know there's kind of a violation. So there is a very loud speaker at the back of this robotic dog to speak out, keep distance, keep distance, keep distance. So we already see this area in Singapore being used. Other things like expert system or recommendation system. What do you have purchased these, you purchase banana, you are also likely to purchase that one, other things. So modern recommendation system. What do you have purchased this product from online shoppers, e-commerce website, you are also likely to buy others. Speech processing, smart speakers are now become very popular. So in my home, I have 3 smart speakers. I let them talk to each other and see which one is smarter. So the next one is natural language processing. Machine translation is part of the natural language processing, which is actually quite magic. Imagine those translation is very tedious and time consuming. We have to engage a professional translator. But nowadays, due to the advancement in machine translation using deep learning, machine translation is relatively good quality. So have you noticed this word? This is called serendipity. You know this word? I have never learned this word. But for the preparation of this slide, I have searched for one of the most rarely used English words in the world. So this is among the top 20. So thanks to the so the machine translation, now we can quickly find out what is the meaning of it instead of looking at a bulky dictionary. Because the greatest strength of the machine is the speed. Human can also do it. I can go through the library and look for that word, but it's much slower than compared to retrieve it from a digital form. So finally, we are doing planning. So from NUS to Changi Airport, there's multiple ways. Actually, there's many different ways. But I may want to find the shortest path to save the oil, or I want to find a lesser transfer if I'm going to take a bus, or if I'm a little bit handicapped, I want to find those accessible paths, right, which is friendly to a handicapped person. Right? Great, so these are many of the some major areas of AI. So let's look at this one. So you see a plug here. I see a plug here. When I see it in China, this is a China plug. Through the sensor, which is my eyes. I take in using my perceptions. So I have to figure out these image in my mind. Then my mom at the time told me, never touch a power socket. Very simple rule, heuristic based. I must say never touch it. So I learned, I just remembered it. I say, whenever I see this pattern, this power plug, never touch it or else I will die. This was when I was young. I was born in China. So more than 10 years ago, I moved to Singapore. And you know, the first time I landed in Singapore, I find the power socket is different from the one in China, right? Nobody taught me that I should not touch it. So how, as Sam, didn't get an electricity shock and didn't die? I'm still here. So some magic has happened, right? So what happened? We utilize some of our recognition capabilities. And this is called similarity-based recognition, right? We are not explicitly programmed. So there is similarities between these two images, and we utilize this recognition capability. Then after recognize, I find that this new power socket in Singapore is the same one. So I apply the same rule, same good old rules taught my mom. So I don't touch it. I don't touch it. So I won't touch the one in Singapore as well. So after that, I will take an act. The act is avoid touching it. That's why I'm still here. Okay, so put into a larger context, not only we have visions, we have other sensors, or you have the CCTVs to capture this information. So we have a series of courses under the domain called intelligent sensing system, which will process and take in those sensory informations and put it into the, stored into the data. Then from the data, we want to generate knowledge, right? Data to generate knowledge. The outcome of learning is to generate knowledge. So we have a series of pattern recognition systems and a practical language processing courses to be mainly focused in this domain. Then in the intelligent system, intelligent reasoning system will be more focusing on the reasoning capabilities. And lastly, when we want to take act and interact in the environment, we have two set of courses here. One is intelligent robotic system, which takes actions in the physical world, interact in the physical world. And we also have intelligent software agents, which is taking actions in the virtual world. So this is the entire program of intelligent system. You see there are 6 vertical pillars, 6 vertical columns. There's intelligent reasoning system, pattern recognition system, intelligent sensing system, intelligent software agent, practical language processing, and intelligent robotic system. So for students, you can take those courses at your own pace. As long as you finish the first 2 pillars, we call it foundational certificate. These 2 graduate certificate 2 columns. Then you take any 2 out of the 4 remaining specialist graduate certificate plus a capstone project. If you are assessed as competent, you will receive a NUS degree in Master of Technology in Intelligent Systems. You can choose stackable route. You take the course one by one at your own leisure, and you can complete the program in up to 7 years. We also have through train programs, which is 1 year for the full-timer and 2 years for the part-timer. For the part-timer, you study every Saturday, nearly every Saturday here. It is specially catered for busy working professionals. That's a great program. So we have looked at human learning. Now we're moving on to machine learning. So machine learning, we have pattern recognition system and practical language processing system. These are the 2 specialists. We also have human reasoning, and from human reasoning to machine reasoning. This is making use of knowledge. Build a recommendation system, doing plannings, doing schedulings. So we have intelligent reasoning system and 3 courses here. The name is much shorter, and normally you know the shorter the name, the more difficult it is. Right? So these intelligent reasoning systems are also offered as a PCP AI program. So if you are interested to know what is a PCP program, what is the benefit for you, stay tuned at 1 p.m. I will go into the depths to that. You will see me again at 1 p.m. So from human perception to machine perception, we have intelligent sensing system, computer vision, one of the most hot topics. And after this session, the immediate next session is Dr. Tianjin. Stay tuned. You will find a lot of fun there. So then last is we want to take actions. If you take actions in the physical world, yes, intelligent robotic system is your choice. If you want to do more robotic process automation and moving from robotic process automation to intelligent process automation, yeah, intelligent software agent is your choice. Okay, well, we will say that the end is a new beginning. Now, please restart your lifelong learning journey with us. Register now. And also, please remember to provide your feedback. You will provide your feedback and you will receive a slide for today. Okay, yeah, I will thank you very much. And I hope to see you at 1 p.m. And in 1 p.m., you will see how to prepare yourself to become a AI professional and get ready for the AI area. And I will also showcase some of our past learners system in the 1 p.m. session. I will see you there soon.